Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. I want to bring to you an abstract from a paper that has just been accepted for publication. It has undergone full peer review, but the paper still needs to go through the copy editing, typesetting, pagination, proofreading, and so forth, which will before it will finally be published in a journal, and it will be published in the Journal of Geophysical Research. And this research is going to be addressing the following. This will be the title of the paper when it gets published: Ocean Modification and Seasonality in a Northern Ellesmere Island Glacial Fjord Prior to Ice Shelf Breakup. And basically focusing on the Milne Fiord. So this is what the abstract says. Understanding the impact of the breakup of Northern Ellesmere Island ice shelves on fjord dynamics is limited by a lack of ocean observations prior to ice loss. Based on profiling and mooring data collected between 2011 and 2019, we described the oceanography of Milne Fiord prior to the 2020 breakup of the Milne ice shelf, including sources of ambient water, under ice hydrography, glacial modification, seasonality. Ambient waters originate in the Canada Basin but are modified by interaction with the 100-meter thick ice shelf at the fjord entrance and extensive glacier tongue at the head. Properties within the 436-meter deep fjord are depth dependent, with freshwater surface runoff and subglacial discharge accumulating in the upper 50 meters of the fjord each summer behind the ice shelf. Freshwater export is restricted to a basal channel in the ice shelf, resulting in the fjord being more stratified and warmer than waters offshore year-round. Below the ice shelf and above a 260-meter deep sill, unrestricted exchange allows warm Atlantic water to penetrate to the 100-meter deep glacier grounding line where submarine melting occurs. Basal meltwater spreads down the fjord close to its depth of origin due to the strong stratification. Interannual warming of fjord deep water is likely driven by shoaling of the Arctic Ocean thermocline and spillover at the sill, highlighting the link between fjord properties and regional oceanography. Further breakup of the ice shelf is predicted to substantially alter fjord dynamics, with consequences for ocean forcing of the Milne Glacier. Now, they also include a plain language summary, which I will now share with you. The northern coast of Ellesmere Island, Canada's high Arctic, is warming and undergoing rapid changes, including widespread breakup of large floating ice shelves. The impact of the loss of these ice shelves on the oceanography of fjords here is poorly understood due to a lack of observations in this remote ice-covered region. Here we present results from a multi-year oceanographic study of the last intact ice shelf fjord in Canada. Notice, last intact ice shelf, which of course Milne Fiord. We find that the ice shelf acts like a floating dam, trapping meltwater runoff in the fjord, which then slowly drains underneath the ice shelf through a narrow channel. Deep in the water column, a layer of warm Atlantic Ocean water flows under the ice shelf, right to the innermost part of the fjord where it melts the base of an outlet glacier from below. Observed warming of deep waters in the fjord over several years indicates that the warm Atlantic water layer is getting shallower with time, which could drive more melting of the glacier. In July 2020, the ice shelf started breaking up, and we predict its loss will fundamentally alter the oceanography of the fjord with uncertain impacts on the stability of the glacier. So there's a lot to say about this. First of all, the overall general thing is that the notion they talk about the stratification. You're having basically more fresh water being introduced, right? And I'm in the middle of doing a whole bunch of series of videos discussing, the freshening of the Arctic Ocean, if you will, what that means in terms of stratification, the stability of the water column, and other aspects. So we're seeing the freshening of the Arctic Ocean. We're seeing this right here. But we are also seeing the intrusion of Atlantic water becoming more and more pronounced. And it's warmer water. It is denser, even though it's warm. It's denser because it has a higher salinity. So it sinks in and starts melting from below. But the important thing is it's starting to get shallower and shallower. Basically, it is starting to, in essence, ventilate, replace the fresher water at shallower depths and starting to replace it all. Basically, this is further Atlantification that we're now seeing in more and more locations around the Arctic Ocean. So this will, you change the density, you change the physical characteristics, you're going to change the oceans. And with that, of course, you could be altering productivity, for example. And I've been discussing that topic as well. But this is the Milne Glacier. When that broke up there, that was like almost the last major ice shelf in Canada, in the high Canadian Arctic, and this has major implications. Now, notice in the abstract it says something about 100-meter thick ice shelf at the fjord entrance. Okay? And we talked about how the water, you have the melt water from above and the warm oceanic water from below. Similar processes that we're seeing in Antarctica with the warming from above, and then you have the warmer Antarctic water getting underneath the ice, melting it from below, and if it's past right up to the grounding line. So basically, any ice that's past the grounding line is basically cantilevered. You melt that from there, you can break that off, and that's what's happening in Antarctica. And that I suspect is a similar mechanism that's happening here that's going to break up the ice around Milne Fiord. So this is further example of the drastic changes that are coming to the Arctic Ocean due to all the ocean heat content that's now in the ocean, and the North Atlantic is bringing that warmer water into the Arctic Ocean, and it's having an effect. And the fact that we see the thermocline, basically shoaling, okay, tells us, and they notice they use the word thermocline, change in temperature. That tells me that the Atlantic water is becoming more and more prominent in the oceanography there, its effect being felt at shallower and shallower depths. Notice also they talk about freshwater surface runoff, subglacial discharge accumulating in the upper 50 meters. That's because it's low salinity, if any, so it's like a freshwater length. It's very similar to the mechanisms I've been discussing here in these videos. So this is just, we've now come to understand the mechanisms quite well, and we are now seeing this take place in more and more location, such that it will actually improve our modeling as to what will happen. So this is further another example changes that are happening. More and more, we're seeing the Arctic Ocean becoming Atlantified. I've discussed with you the Barents Sea, for example, we're now seeing the same issue in the Laptev. Right now, most of the Atlantification observation have taken place over the shelf on the Eurasian side. This is now on the North American side, and that tells us especially when you consider the movement of currents, the fact that the North Atlantic water is now basically extending its effect more westerly than towards the east as it enters, through the Fram Strait or West Spitsbergen and so forth. That tells us that its influence is increasing, and this will contribute to ice melting, will contribute, along with everything else I've been discussing in these videos of late, how it looks like we're heading for a blue ocean event. Granted, that's with the sea ice. This is talking about glacial ice, but still, if you're losing all this ice here, that's going to have dramatic changes. So, the old saying goes, stay tuned. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.